So, the random error component, how to deal with it, is derived from the limited accuracy of the measurement equipment, has to be described and quantified, and we use the random M. And the good news is that the random error behaves normally. So we can deal with it with a normal Gaussian distribution. And this is the matter of this unit. What is the normal Gaussian distribution? Okay, it's a very important tool of distribution. There are many types of distribution. One is the normal distribution because it allows us to model many natural, social, and psychological phenomena. Yeah, so it's a modeling tool. To each measured value belongs a certain measurement precision. So two parameters, mean and dispersion, characterize the result of the measurement. So that means for each population of measurements, for each population which or sample which represents a specific phenomena. For example, the distribution of ages in the age of the people in Namibia, the age distribution, or many other phenomena, the height of the trees, the age of people getting corona, whatever, which is normally it follows a normal distribution. Okay, so and each population, remember from the last unit, can be described using the mean and the standard deviation or the variance. And this is also how you study the normal distribution. So a normal distribution is a symmetric distribution. So it's not a skewed distribution, it's a symmetric. It's completely defined by the following parameters, as I said before, the mean and the variance or the standard deviation. What is the main function of the normal distribution? Okay, it's basically estimate, once you have a specific data set, estimate which is the probability of your distribution to adopt a particular value. Yeah. So one example, we have the distribution of the ages of the people in our class. So we have maybe people from 18 or 19 to 25, let's say. Yeah. Or let's say 30. Let's exaggerate it because we might have someone who is very young, 18, and someone who is not very old, but a bit old for the student standards, 30. Yeah. So what is the probability to have a student? If I pick any student from a list to find someone who is 30 or 29. Probabilities are small because they are in the extremes. But what is the probability to have a student to pick a student with an age maybe with 22, 23? Maybe it's much higher, yeah, because most of the students are between 21, 22, 23. So this is what the normal distribution does. This is what we are able to model, yeah. So the density function will calculate the probability of my distribution of my population to adopt one single value. That means if we select one element randomly to have that one we select to adopt or to have one specific value. Yeah. And what is the distribution function? The distribution function is very similar. It's an integration of the density function. So you can see the density function is fx and then an expression. In this expression, we know all the elements. We know x is the value that we're going to calculate, mu is the mean of the population, sigma is the variance of the population, the standard deviation of the population, and then sigma again. The rest are numbers. 2 is a number, p is a number, pi is a number, and e is a number, the number e. Yeah? We'll see this later. We have exercises with this. So the distribution function is the integration of the density function to calculate intervals. So now with this distribution function is going to give us an estimation of what is the probability of having what is the probability of my population to adopt values between, for example, 20 and 25 years, 22 and 28. more than 18, less than 30. This is what is able to do the distribution function. And this is what is normally more interesting rather than just calculate the probability of adopting the population at a specific value. Okay? Check the time. Okay, let me stop here. We continue in the slide number 8.